So let's see. I'm going to share my screen again. Let's okay, so my suggestion, if everybody's amenable, is since we have a smaller group left and the ambitious agenda we had is probably too much. Huh?
Can you show the original schedule?
Yeah. So let's look at the original schedule. So we can kind of have a general open session where we can discuss these themes for as long as people have energy. But I don't think it now makes sense to have multiple tracks and multiple sessions, since we have how many people? We have 13 people left. So congrats everybody, you made it to the end of the robot showdown and winning by LRA. LRA won, right? Size
no, AFW won.
AFW won. Oh, yeah, AFW controlled by Sai won. So if everybody's okay, what I'll do is I'll start up a debriefing page on Roam to take notes, and we can just have like an open discussion on all this. But this material we have prepared, we can actually use it for future sessions, deep dives on these topics. But I think today it might have been too much to plan for this. Wait. Sorry, I'm trying to find my Roam page here.
Okay, so meanwhile, let's talk a second about what you learned. Does anybody want to describe a surprising experience that they had controlling these rovers or watching them walk around blindly?
So just a quick word before we enter that is that it may look odd how this demo is going, okay? But all the problems we got, the connectivity of dropping frames of video, we're losing video and hitting the walls and so on. This is something we can see in missions to Mars and so on, where the latency is very long. So there is no attempt actually at remote control, okay? And so this is one of the goals of the demo, is to feel that to some extent and how frustrating it can be.
Yeah, I'm just taking notes, so people just feel free to share your reactions and thoughts.
And just in case anybody wonders, just a few hours ago, there was enough bandwidth, nothing crashed, the robots walked straight, the video stream was good. Okay, so when we tested it all on Earth, it was fine. Just apparently Tokyo at night, Godzilla is not the only problem.
I think my reaction to that is more or less what Eric said, that lag is a huge problem, and also perspective-wise, I guess I think about navigating from using my body where I have a view that's more than a meter above the ground, and when you have cameras a few centimeters above the ground, it's a very different problem.
And I guess we are trying to issue some commands, and since due to the lag, we might need more autonomy in executing them. We want to issue more abstract commands and have them implemented in a way that is sensible to us, but still accounting for the lag.
Yeah, the rover could reject commands that will make it stuck. For example, if it's quite clear that it will get stuck, so that commands could be rejected.
Do you have a feeling when you control the robot, when you had a video stream, what commands would get it stuck? Was it easy for you to figure it out?
When the drone video feed was there, it was easy to figure it out. But otherwise,
you had a lag, and sometimes the rover continued moving, you know, after you gave it a command.
I guess I could orient myself to the rover's view a little bit. One time it was completely blank and I thought I had to go straight, and maybe it was because it was going straight. It went well. I don't know.
So one of the things that struck me was how all the things we talked about earlier on in the non-interactive demos, you can see the implications they have further down. Like in my building, all the sort of jankiness of things falling apart, that was like offline during the building process. But throughout the demo we just saw, Eric was like refitting. Was it a battery that kept falling out? Like something kept falling out that you had to keep putting back into the SpiderBot? What was that?
Yes, it was a battery.
Okay, yeah, so you kind of have to anticipate this in the design phase, like how the sort of mechanical fragility affects operational capability, right?
So here we had a problem. LRA, when it walks, it veers to the right. Okay, and you know, just a few hours ago, it had the opposite problem. One of its left legs didn't move properly. And I think it's not about making a correct step. It's the sequence of steps has to change. In other words, if you think you can walk forward 10 steps in a straight line, no, you have to walk 5 steps, turn left 4 times, and then do it again. So it's a level of compensation for unexpected problems, which is more than just this wheel is slipping, so we have to give it more power.
This is precisely what in hand robotics I'm going to work on. Like the idea is like in industrial automation, you can control all the environmental factors and you can train simple Gaussian mixture model or something to imitate something someone is doing. But then how do you go about it in the real world? Do you they made a reinforcement learning agent that can take in the image data and fix the policy of the smaller controller, accounting for the noise and the changes in the environment. I guess that level of robustness is, you need the image data to make sense of it, like how we use the drone today to orient ourselves. And
yeah, but imagine you're a cockroach in the dark. You don't have eyes. All you have is antennas that bang into things and tell you where to go.
That's some form of feedback to control change the policy in the real time. Like
I think there's a mix of like you need the feedback and you need feedback at the right level of abstraction. So there's feedback at the level of I want to go 5 steps to the right, and you regulate to, you know, count down 5, 4, 3, 2, 1, and you're now pointed where you thought you were going to be. But there can also be feedback at the level of I want to go towards the hut with 2 bottles, right? And that's a much more robust way of stating the goal. And then even if there's a bias in the robot or something, it'll compensate automatically. If the bottle is, if it moves 5 steps to the left, but the bottle is still not dead center, it can then like readjust and go 6 steps instead, right? So it would be good to get a command language that's at the level of abstraction of goals, but then the feedback control is 2 levels. You've got like the feedback outer loop at the level of abstract goals, and then the inner loop at the level of regulation of quantitative commands.
Yeah, if you remember, I shared something called clipport, which was trying to use natural language, that clip model, to be the sort of the abstract thing, like use natural language as a goal or something, and then use that. I'm not sure, I forgot exactly what they did for the hand robot, but they used the language as the abstract goal stating mechanism. But maybe natural language might be too abstract or too ambiguous.
But ultimately, this is something that maybe we would like to have, is that we just tell one of the spider, okay, go get the huts directly. The problem at the end of the day is how we translate those high-level concepts into low-level servo control, basically, right?
Yeah.
I'd like to hear more from the people who are seeing all this for the first time. So any thoughts from like Rami, Ritwik, James, Phil, Nalini?
Maybe if you could ask specific questions to just sort of prompt the observations. I don't know if that would be helpful.
I think we actually had some prompt questions for the town hall plan. Let's see if I can bring them up. Ooh, we have a lot of slides.
Wow. Yeah.
Yeah, so we had like 34 people registered and we planned for a few double track questions, but okay. Yeah, here's a couple of prompt questions. What would you like to do if you join the project, and at what level would you participate? So yeah, let's try the first one. What would you like to do?
Sure. I'm not sure what I'd like to do, but I think yeah, this was very interesting, and showed me how much I don't even know what I don't know in terms of all that's involved with getting these things done. Obviously, I've built remote control robots from kits and stuff like that. So, and I think the level of expertise on this presentation was obviously above the sort of level I've operated at. So I'm really at a learning stage. So I kind of put the question back to you guys of where are the bottlenecks here that a person who doesn't necessarily have the same level of expertise, how can they first level up to that, and what is it you guys need?
Yeah, I think I agree with you, Brian. Like there's I've not even learned a lot, but just seen how much I don't know about, for instance, the mechanical engineering side and the control side. And now we're talking about sort of planning movement as well. And I don't, I need to get some kind of awareness of all of them. The one thing that occurred to me watching that was I was reminded of the robot vacuum cleaner I have, which according to the little app I have on my phone for it, does what I guess you could call a basic kind of slam, where it tries to map out its environment, and it doesn't even have eyes, it just bumps into things. It has wheels and a bumper, and that's how it figures out pretty much everything it knows. But it still manages to put together a reasonably usable map from that. And I was wondering if, as a target, that would be something I might be able to try for a first build. But I haven't even built a robot from a kit before, so I don't know if that is the right level of ambition, or far too ambitious, or what.
I have like a sort of adjacent response to that, which is perhaps not directly responsive. But one of the things I learned from doing what I did this year is when you work on this stuff in a more professional setting, as in like in a grad school or a company, typically nobody ever lets you do the whole thing, like the entire stack of like building the entire robot, choosing an electronics board, programming it. Like everything I did in the sort of more professional engineering period I spent on this, I only was ever given like a tiny little glimpse of one tiny subsystem. So I might have been working on like a small coordination algorithm, or like a little bit of like a payload component. And I think actually given the choice, I would say everybody starting with this stuff should actually start with the big picture, which is exactly the opposite of places like big companies or universities they want you to start with some tiny piece of the puzzle, and you may or may not ever get to work on the whole thing ever. Like maybe you've become mission director at NASA. Eventually you'll ever have like some idea of doing bird's eye view level thing on an entire mission. But I think that's actually perhaps the most valuable perspective setting thing. Like this has given me a sense of what I'm good at, bad at, what I don't know versus what I do know. So I would recommend, to the extent people are able, to do a full stack complete build, even if it's of a very, very simple robot. I would say that's probably the best starting point, as opposed to like, yes, I mean, if you asked me, I could use help on pieces of my build. And if somebody wanted to, I could give them a little piece to work on. But I think the best way to actually get started is to actually do a whole robot, like full stack. And then second year, I'm already planning to specialize a little bit, but this first year trying to do the whole thing was hugely helpful.
And fun.
Yeah.
Is it your goal that, you know, it's there was some of the presentations were about interactivity and talked about interactivity between robots. So I'm assuming at some point you'll identify sort of prototypes that you think sort of will move the project along, and then at some point you'll need to build, you know, multiple numbers of these prototypes. So you'd have to create some build capacity for that. So like, I don't think I would have enough knowledge today to sort of come up with the concept of building a whole robot from scratch.
Oh, I didn't mean build a whole robot from scratch, like even a kit robot, like, you know, any of the $100 kits on Amazon that do like a Raspberry Pi, just something that allows you to touch everything from wheels and motors to boards to software. And to your point, like, yeah, we do have plans there, but we're already along that way. And you don't need everybody building the same robot. You could have like totally different robots, so long as they all are running some basic Linux single board computer that can run Docker and stuff. We already have some capability for them to kind of like interoperate and do social stuff. So we did that this year. Like, yeah, Mayor, you want to speak to that? Like the sort of minimum viable level at which you can do collaborative stuff?
Well, we didn't build it yet, and maybe I should emphasize the whole point of what we're doing is we're learning by exploring. So the minute we build it, I can give you an answer. But what I've been working on with Victor is some sort of mechanism whereby one rover can send a request to a different rover. Okay, so it's one level below. You know, only have two ants picking up a piece of bread, a crumb. So we're not even talking about that. We're even talking about you have two rovers. One of them has experience image processing, and one of them has experience figuring out how to knock over water bottles. So how do you transfer the experience from one robot to the other? How do you even ask for it? So we're starting by trying to build the protocol, and then we're going to try to have the robots pass a question of some sort. I'm not sure what, back and forth. And what we're trying to do is we're still looking for the correct abstraction levels, which will allow these requests to be meaningful. And you know, these rovers are actually pretty similar. They all have cameras. They all move on a surface. Okay, these are great similarities. You can imagine a different rover which moves passively, and they're planning to send one to Mars, gets blown around by the wind. You can imagine a rover like a cockroach that doesn't have a camera at all. Even when we're talking about SLAM, okay, which is a great algorithm for mapping out where you are, the question is, do you need to have a correct map, meaning geometrically correct, or is it maybe more conceptual map is meaningful enough for some rovers? So we're not there yet, but the way we're going to get there, that we know. We have a certain diversity of rovers, and we've decided they're going to talk to each other, and we're going to force them to talk to each other, and we'll discover, you know, what we need to do in order to get it to happen. And as we do that, we might define what kind of rovers can talk to each other. We might classify tasks according to how easy they are to distribute. I have no idea yet. I hope that answers you, because the answer is not, an answer, but what direction we're going in. But you talked about building, and Eric mentioned we have a variety of rovers. I think it's intentional that we have a variety of rovers, each one with different capabilities, because it helps us get a better view of what it means to be a rover and what information you need and what it actually means to have that information. I mean, if you remember, we had 2 rovers and a drone, all of them blind, in the dark, in a very simple geometry. So what I was asking myself was, what do I have to add as autonomy into the rover to make it capable with existing hardware, capable of dealing with that surroundings? Okay, so that's how we're moving along.
And I think machine learning adds an interesting dimension to this. So you have like diversity and social capability with like a minimum level of interoperability. That's one level to enable that. But when you have situations like all cameras being blind, well, basic machine learning abilities can kick in, like Sai demonstrated, like image-based classification to like just obstacle or not and turn and move around. So if the camera feed drops because of like twitch frame rate or whatever problem, but still locally the camera is accessible, the machine learning local feedback loop can still make use of it. So one way to think of the architecture is the top level supervisory control from like remote locations fails, like, Earth to Mars control fails because of like various communications problems, but then the local loop kicks in and it at least does like a baseline attempt. It might be dumber than the remote controller, but it's local and it's actually there and it has some ability. So it keeps trying to do stuff. So I think, yeah, machine learning is another level at which you can do this, including social stuff. Like the very last phase of the game, we had the 2 rovers both close to the robot, and one of them had lost control. And I think AFW won because it had more control at the crucial moment. But if it had worked differently, then LRA might have autonomously still been a contender at the last minute.
I think perseverance or something has a bit of autonomy to do what you are saying. Like I think when due to the lag, and I think coming out of the pit or something, I don't remember, but I'm not sure whether they are going to put the software for that, or like going to send it or something, or it is already there. Some level of small autonomy to compensate for the lag in the teleoperation phase.
So I have some thoughts and some inputs into potential ways I could help. So the way I see it, we have sensors, actuators, and communication link. It's common to all these devices, right? So they have sensing capability, either cameras or any other microphones, etc. And actuators in terms of being able to walk around or move your arms, and then the communication link to communicate to remote users or fellow devices. So if the communication link fails, just to continue on the previous 5 minutes of discussion, the communication link fails, the sensors and actuators are still local, and they can, on top of the compute engine that's on there, they can do some things in spite of not having the communication link. So when the communication link is present, if the devices need to talk, one way could be to have a mechanism to publish their capabilities as in an abstract manner with the verbs shared in a common language that all devices understand. For example, one device could say, I can look around and tell you what's around me, or I can move my arms, etc. I can walk, or etc. So advertising your capabilities would be a way you build a dictionary of what various devices are capable of. And then when one device wants to read off the other device's capabilities, then it sends a request and so on. So we need some kind of dictionary to publish what you're capable of, and then also take commands and act on that. On the other side, so I remember the original intent was rovers to Mars. Is that still intact? I haven't been in touch for a while. So is there any scope of doing some on Earth applications? Or
Yeah,
is it
the Mars
purely...
thing is like a ambitious 10+ year goal, but along the way we are like super flexible what we do. So yeah,
Okay,
totally in
so
scope to try and do Earth robotics for a while.
right.
Learn.
Can you
So
go to
that
the previous slide, Venkatesh? Just a second, it's super relevant.
Which slide?
That one, yeah.
Yep.
So I think the reason I asked that is the communication links are fatter. We have fatter bandwidth or fatter pipes when we are on Earth. Not as much bandwidth when you're in a building, but still better than Earth to Mars communication links. So given that, if we were to think ahead and say, how do we update the devices once they are deployed, and thinking about over-the-air firmware updates and how to coordinate all that, we might want to start thinking about a mechanism that all these SBCs, single board computers running Linux, can have a FODA, firmware over-the-air capable component to it. So that whatever we do, it's not build and deploy, but it's build, deploy, continue to evolve in the field, instead of having to bring them all into the lab and update.
Yeah, this is already part of the Mars missions that currently exists, I believe. Like because resources are so limited, Perseverance, for example, used the same computer with a different operating system for the in-flight mission phase. And then when it actually landed on Mars, they did an on-air update to replace the flight computer operating system with the roving operating system. So yeah, and I think one of the interesting things we've talked about before is Elon Musk, in the terms of service for Starlink, says that you recognize Mars as a autonomous, ungoverned zone, and it's kind of interesting. It seems like a joke, but if his plans work and he puts a Starlink constellation around Mars, we can actually think of like fat pipe futures on Mars as well. So it could be that if you build for like much richer Earth capabilities, by the time Mars capability comes online, hey, you don't need to build more outlaw capabilities for Mars. You might actually have the Earth grade infrastructure there.
Right. Yeah. Right. So my focus or interest in the past 1 to 2 years has been systems engineering as a discipline, and I think systems engineering is common in industries that have a wide-ranging impact, like building airplanes, satellites, etc., and not so common in consumer oriented industries, especially if it's not healthcare. So looking at the whole picture, looking at all things that are involved or impacted, etc., could be something we should start thinking about for various devices. And because all these different projects are aiming at the same solution space, we have the same problems. And so some systems engineering thinking could help everybody. I mean, all the projects, I mean. So that's a place I would like to get involved in whenever we start doing that.
So one of the things about this project is it looks like many projects, but it is actually just one project. We kind of all have like a ongoing collaboration soup, but it's we're in what we think of as a muddling through operating mode, where there isn't actually a specific time or like schedule or roadmap on which to do stuff, even though we're using the term roadmap. So yeah, if systems engineering for systems like this is a direction that really interests you and you want to join, I don't see why we can't start doing something on that already. Like we already have bits and pieces that could sort of fit into a systems engineering research and development direction. Like we have the lower layer of like VPN, Docker, all that stuff. So we're starting to build the infrastructure for things like on-air updates. And then, yeah, I think the time to think about like how do you actually build an infrastructure to do that could be January. Like you can start doing that now. Like, can you do an over-the-air update for whatever headless Chrome is talking to the server or something? Can you do that right now? So I think there's possibilities right now.
Yeah, I mean, this is not a unique problem, especially with the Internet of Things panning out over the last few years. Firmware over-the-air updates have been abundant in terms of options to choose from. Different vendors have different solutions, Yocto builds, or I forget all the names, but you basically build a component into your system to be the supervisor for administering or communicating with the FODA server and putting that image in, booting into that image, etc. So, but we could, I could do a small study of various options in present, and then we could see which one's a better fit, and then we could start integrating that into the various builds.
Yeah, I think that would be a fascinating thing to, or thread to add to the project. All right, quick
That's all.
time. Yeah, go ahead.
That's all I had. Thank you.
Oh, okay. So quick time check, 11:05. So I guess we should start wrapping up. So other comments? Anybody who hasn't yet spoken? Ritwik, Rami, or Brian had something to say. I think, yeah, go ahead.
Oh, I was just wondering if, since your goal is to make these autonomous, have you thought about how you're going to keep them charged? Just wondering if that's you've done any work on that. Obviously, I don't think putting in, Perseverance nuclear reactor on it was probably viable for at least here.
I mean, I think several of us have thought about like just autonomous plug-in capability, as in like find a wall outlet and go plug yourself in. I've sketched out a couple of designs for that, but I gave up on that for the first year. And of course, the moment you decide to go outdoors, solar power becomes a viable option. And I think several of us have solar power somewhere in our build roadmaps, and yeah, on the collective roadmap as well. I definitely do. I'm planning to buy a solar kit for next year and play with it. Anybody else have power management ambitions for next year?
I just want to say this was very interesting and pretty amazing.
I had a quick thought on harvesting energy. The amount of energy you can harvest from small things, motion, etc., and vibrations, that helps to build the reservoir capacity of the battery if you're not expanding much all the time. For example, it works if you are a sensor in the field, stationary, and just publishing data every so often and go to sleep most of the time. And you could have a small solar powered battery or even more capabilities to harvest energy from the environment. But I don't know how viable it would be for high energy requiring application like this one, where we have mechanical motion, and that little amount of harvesting does not go far. Yeah, just a quick thought on that. That's all.
Mayer had a sort of a speculative concept very early in the year of like tumbleweed type rovers that just get blown about by the wind, right? I forget the details.
Yes, except when it was just a concept, but when I contacted the Mars simulation station in Israel, they told me, yes, just a few weeks ago, we ran an experiment on this project that has tumbleweed robots that passively get blown on Mars. Okay, so I might have thought about it, but they're actually doing it. Some group I posted it in the Discord. But yeah, power is a big problem. But one of the ways you solve it is considering it a resource which can be traded. And the whole issue of communication between robots and an economy with base stations. If you have a base station with a power field, it can charge up robots and get paid. You know, if you're a base station, you can do roving by proxy. You know, if you want to have 10 hours of power, you have to give 2 hours of movement to the base station. So the solution might not be making the rover self-sufficient, but rather building a working economy of rovers. And that's why we mentioned the blockchain at the beginning. Okay, because it's, you know, one way of having reliability when everybody cheats everybody. And that's just something to think about, because definitely a base station can have a solar field that can get powered by satellites. It could even be nuclear. I mean, imagine one of the rovers we have now on Mars, all of the wheels get stuck. It can't do anything anymore, but it still has a nuclear reactor. Okay, now it can sell it.
So the rovers pay for power with data that they collect, or assignments they complete?
Or with time. In other words, you give me power, but now you go check out that dried lake and bring me 4 samples. And, you know, you can just think about blockchain being used for the rover to prove that it actually went to the location it was supposed to go and collected the data it was supposed to get. And then it's expecting to get the power, which was in the contract, you know, smart contract that was supposed to have. So I don't know, it's just a use case, but it's not just money, it's resources. Yeah,
and money actually makes this even more interesting. Like if you give me imagery, but I give you power, but I don't want imagery right now, but you pay me in tokens, I can use the tokens to buy something else somewhere else. So if you have enough rovers from enough parties in the same geography or Mars geography, it opens up the possibilities. Like I buy from you, but you use the tokens to buy something else from somewhere else. So imagine a future Mars where, you know, different countries have dozens of rovers, open source groups have like dozens of rovers. The more you have, the more non-linearly you can like do economic transactions this way.
What, do you know of any studies which talk about how many individuals you need to have, or how many transactions, so that money is better than barter?
That would be an interesting question. I'm sure people have done research on that, but yeah, economists talk all the time about the concept of dual coincidence of needs, right? It's a very unlikely coincidence that I need imagery at the same time that you need power within a window that we can exchange. Whereas if you have like 10 people with different wants and needs and you have tokens, a lot more clearing of the market can happen. But, yeah,
I have a quick comment on like what people can do. Maybe like as Anuraj pointed out, you might not even need a rover. Like you can, if you are in software, maybe you could start with simulation and try what is exploring stuff like what is a good navigation algorithm which might make sense for Mars, and especially with simulators becoming more and more photorealistic and powerful, you could probably get away with some of the software capabilities which you could develop just in the simulator, and maybe that could also be useful for the project in the long run.
So along those lines, we did start a stub page for things we need, but honestly, there isn't much there yet. But yeah, it's open to a lot of, where is this page? I thought we had that somewhere here. Well, there's a page somewhere. Hold on, I think let me find it. Comment. Oh yeah, things we're looking for. So we started this page. Most of them are at like very granular tactical level, but really what we're looking for is people to join in sort of a self-starter way. You see something that you think needs doing or is fun to do or would be a valuable thread to add to the project, just join us and start doing it, and we'll figure out how to like connect the various value streams later. I think through the first year, one of the things we learned is it's just fun to have like a group to work with, and then sort of let the coordination and mutual contribution opportunities arise as they may. So this first year, we've been mostly kind of like independent, but we still met every Monday to like discuss and swap notes and stuff. Limited amount of collaboration. Eric and Mayor worked on the spider bots together. Victor did the Docker VPN stuff, which several team members used. We swapped like tips on 3D printing, things like that. Second year onwards, hopefully we'll do more deliberate collaboration, but the intent is still like pure improv theater. Just show up. We meet every Monday at 9:45 Pacific. So that's, I forget what time that is UTC, but we'd love to. So those of you who stayed with us through the whole session, so thank you for that. And it would be great if you joined us on Mondays and kicked up a piece of the project that you enjoy. Any other closing thoughts?
If you were giving yourself some advice or guidance this time last year, what would you have said that might have been different?
Not sure I understand. This time last year, this project.
Well, I'm saying is like when you kicked, this is a year in,
Mhm.
would you have done anything differently than what you've done?
Not me personally, like on my personal thread of activities, I was like never more than one step ahead anyway. So it was like fumbling in the dark all through anyway. But yeah, the project level, I think we did apply some lessons from like the previous Yak Collective projects that had, I think, too much structure perhaps. So this one was deliberately much more improv and self-started, self-guided, and then collaborate as possible. So the default baseline of activity is do what you can individually, and then any collaboration you manage to spin up is a plus. And I think that default that we adopted in January turned out to be very good because it turned out to be a very solid basis for participation.
There was Oh, so sorry, just to add to that, at some point, we had some questions like, we have only build leaders basically, okay? So there are as many members as leaders basically, okay? So we are all leading, okay? But that was also intentional, at least for the first year. It's to maximize exploration depending on everyone's strength and interest. Okay, so that after we meet only once a week and we mix all our knowledge and our trials and our ideas, and we act as a filter to each other to learn and to. I'm not good at mechanics. I studied that a long time ago, but when I look at what Venkat is doing, it gives ideas and so on. Okay, and so it was intentional to proceed this way, but a couple times, at least, I came back to the question: is when do we move from exploration to exploitation? That is not to have only build leaders, but to have fewer builds and more people working on a single build to do more, basically, in a way. Okay. Honestly, now I think I wouldn't do that. I would not do what we have done differently. Okay, but the question is something that I'm wondering. Okay, and as we are, it's like a funnel. Okay, is that here we are at the entrance of the funnel, and at some points we'd like to have maybe a single build, perhaps. Okay, but we don't want to miss the opportunity to have to be very innovative on some points, whether it's the mechanics, the mechatronics, the electronics, or whatever, basically. Okay, and I don't know. As a retrospective, as you ask the question, for me, the way we are doing it right now to maximize exploration is first is it's fun. Okay, it's very interesting to hear what others are doing. I don't know. I'm learning every week something. Okay, and but still pending is when do we kind of start converging if we want to do it, basically.
One of the thoughts I had was convergence doesn't actually have to be a coordinated, synchronized decision that, hey, we are going to do a shared big build, blah, blah, blah. Like I actually put down in my own goals for 2022, without waiting for the rest of you, since I'm enjoying the mechanical part already, I thought I would just start designing like a more ambitious rover for which I do not intend to do anything other than the mechanical part. Because then I just leave it open to whoever is ready to do say the compute or wire harness or whatever. Whenever they're ready, they can start doing it. But I think the interesting thing about the rover stack is it's actually naturally decomposable. It's got mechanical, structural, motor, power management, compute, software, AI. There's some natural decomposition lines. And so long as you kind of stick to those decomposition lines, which of course is only a part of the design space, but to the extent you can, you don't have to wait for convergence. You can do things that increase the probability of future convergence. And if enough people do things that increase that probability, you have convergence, right? So I think, yeah, even without actually planning for it, we'll get some convergence soon.
Yes, talking about convergence, in my talk, if you can open up the slides, Venkat. So I was looking into various robots. So I have this, bought a kit for this robot, which is another robot I'm building. It's called...
Let me find your slides first. Hold on, quick.
It's much higher, much higher. It's
here.
Yeah, the first one, yeah, $50 to $100. So yeah, this is like a modular robot, and this can be converted into various like a humanoid robot, a quadruped, a wheeled robot with mechanism. So I have bought a kit. So this is just the electronics for it, but this is the kind of humanoid robots you can build. So I've printed at least the humanoid part of it. So this is I'm trying to build it, but I have not been able to assemble it yet. So this is one of the directions we could go, and it's also programmable by Scratch. It's like a beginner block-based programming language. I think it was created at MIT, so kids use it to program it. So a lot of people can get involved in this. It's really nice. I've been experimenting with it, but let's see how far it goes.
Yeah, that would actually be a good convergence target. Like once we decide we are starting to converge, a good way to like point that convergence towards something is something like the Open ROV project. Like, can we build something low cost, cheap, easily replicable that then a lot of people can build a copy of and start using, like, and therefore like use any work we've done. So something like this would be kind of interesting. By the way, while we're looking at your slides, since we did prepare all this material, I do think in January, when we kick off the new year, a new round of meetings, we should actually take the opportunity to run these sessions anyway and have people join them. So we had these newbie sessions and the rover operating system session. We should run these sessions. So we'll just take today's agenda and like run it over more days or more meetings.
Yeah, there is another aspect also is on convergence, is that one of the goals of the project, one of the vision is that we think there will be a growing ecosystem of companies and people who want to make a rover to send to space, especially as the price goes down. So for science, for economy, whatever, okay? And so in the project, the convergence could mean that, we are basically developing skills here. We are developing Lego blocks, okay? Pieces of open source software, open source designs, open CAD and stuff like that. And so blocks that we can put together for a project here and a project there by ourselves, by a group of us, by some other groups and so on, okay? So convergence could also mean that, possibly, okay? It's convergence toward an ecosystem of tools and ideas and experience and experiment that we build up, okay? And so that's why we've been lucky to talk with people like David Lang and Frank, who work on open source and on sharing their ideas and their design. So the ecosystem, the economy around everything we are talking about, it's not only about a single design. It could be a single design for basic demos, but I think it's more about the tools, the capacity, the knowledge, and the pieces that we can later reuse.
So on that note, since Eric, you're going to be project managing next year, yeah, so maybe you could speak for a few minutes for your vision for how to take this forward in 2022 and any sort of directional guidance you want to give us.
Yes, would you mind to show the slide, toward the end when we talk about year 2?
This one?
So, yes, thank you. So the thing that I'm not going to be a decision maker. It's more about what we want to do, what we decide as a collective to do. But the original plan was roughly that year 1 was maximizing exploration. So we do whatever we want, we learn, and we exchange. And perhaps year 2 is start converging in the sense of working more together into building something perhaps more substantial. Okay, and after we have maybe a 10-year plan where we are basically trying to send something to Mars. Okay, because it's not only about building a rover; it's about building a mission around a rover as well. Okay, and so now we are at the verge of starting year 2. Okay, and so. So for the people that I would be managing, but managing is more about being a scribe, basically, and about making sure that the discussions progress, basically. Okay. So I don't feel it's much more than that, basically. Okay. But here on this slide, there are some options that have been proposed. Okay, and so without spending too much time on it, is there a specific interest from existing members, but also new potential members? Okay, that you see the option 1 is about building cheap swarms, okay, meaning that we continue of having many build leaders doing maximizing exploration, okay, and we focus on cheap rovers. So cheap rover is more about because we have the number. Okay, we can have a mission and we can lose rovers. They will be replaced, and this is where the economies between rovers and so on the blockchain become very interesting to explore. Okay. Option 2 is to focus more on rovers for Earth. Okay, and this is very interesting because we can have more tangible economic impact, basically. Okay, and still working towards space because there is much in common in terms of engineering. Okay, it's also simpler in the sense that we don't need to have protection against radiation and so on, stuff that could be added later, perhaps. Okay, so we simplify the problem. It's still challenging. Okay. Option 3 is more about it's a different angle at approaching. Okay, it's focusing about to focus on some component that is more specific and that is used across rovers. Okay, so typically the operating system. We could not discuss it today, but we will have a session in January if you're interested. And the last option, so movement focused. Okay, what was this one? Sorry. Okay, movement is the sense, not mobility. Movement is the sense, okay, creating a larger community like OpenRov. Okay, it worked really well for OpenRov. I mean, it's used in many countries by many people. It's very compatible in the mindset of what we are talking. Okay, so sorry, it was a very quick reviews of these options, but if there is a majority interest already, I am delighted to facilitate whatever we choose. Okay. Can we have a quick round of opinions if there is interest, or maybe we can't really raise hands, but something like raising hands?
Well, cheap seems fun and some mission focused scenarios like today we had. Like if we could do that with cheap swarms and more people could participate, that sounds fun for next year.
So it's still toward option 1 then, right?
Yeah, at least from my opinion.
So I like some mix of 1 and 4, which are kind of like similar swarms and a movement to build cheap robots. So the social movement kind of like creates swarm-like mission scenarios. And the reason I like that is it also creates like an environment to keep learning for a long time. So even though we do want to switch from exploration to exploitation and more convergence, having like the unit of operation be a tractably small, cheap rover gives everybody a chance to keep learning. Like today, if you put me on the JPL Perseverance team, I would be super intimidated. That's like way too complex and difficult a rover for me to contribute to. Whereas something that, even if the project has been going for 5 years, but the unit of activity is like a small $1,000 rover, it would not be that intimidating. And I think that would be interesting for me. So keeping it sort of like accessible scale for constant learning, even if we switch from learning year.
1 and 4 seem to be complementary, kind of.
Yeah.
Yes, there is a difference between option 1 and option 4. Okay, it's on the focus, because in option 1, on the cheap swarms, there is something that we talk about regularly, and that could interest many people, is about scavenging. Okay, so you see, when we see the flagship missions to Mars with like Curiosity and Perseverance and so on, these missions cost a lot of money. Okay, And the thing that it's almost whether if there is a single point of failure, okay? If Perseverance crashes on Mars, end of story, basically, okay? And so this is where chip swarms can be pretty interesting, that we have a lot of chip rovers, okay? So if we send 100 of them and we lose 20%, we still have 80% of the 80 rovers remaining to complete the mission, basically. That's one step. But the other step is that out of the 80 survivors, on the way, if some of them break components, can we have the swarm reconfigure itself to lose some parts and just keep the parts that are still working to continue the mission, basically. And so that's things we talk about when we talk about option 1 as well. Okay. Option 4 is more about the community. About if we take OpenROV as a model, OpenROV converged to a single base design on which we could different groups could work around, right? Okay. So at the end of the day, we still have chip swarms, but it's the focus is different. Here is more about the design of the platform itself. Okay. It was just a quick word about the difference between option 1 and option 4.
I would say option 1 is more of a superset of option 4 because, yeah, if you have option 1, you have all the scavenging capabilities and like swapping of parts and stuff. But even if they're not like, geographically close to each other, maybe they're like widely dispersed, like, on a community on Earth, they can still do the independent things and like share software, for example, or share knowledge. So yeah, I would say option 4 is a little bit of a degenerate version of option 1, which means it might be a good intermediate goal, like get to option 4 and then have like a big open rover camp and everybody goes to, I don't know, Finland or somewhere, and then you can do the option 1 mission scenario where, I don't know, you throw an asteroid at it and break 20% of the rovers and then get the other 80% to scavenge them and figure it out.
There is something that I remember from when David Lang joined us to explain about OpenROV. That makes me think that option 1 and 4 are different. Is that David explained that OpenROV was basically founded by 2 guys, okay? And there is a tech guy and the community guy. David was the community guy, not technical at all, okay? And this is, to me, one of the differences that Eric was the tech guy. And so he was really the option 1 to build the chip swarms. And David was focusing on option 4, on the movement, on the community, okay? And I remember David explaining that it was really complementary, and the excellence of the hardware and the technology, and also all the work that David was spending on the community, on answering questions, on collect opinion from different people, on really creating the movement and making it bigger, okay? So in that sense, they seem to be somewhat orthogonal. They require very different kind of capabilities, and so it's in that sense that that I understand them. Okay, sorry.
Yeah, that's fair. Yeah, the community part is not part of the superset kind of thing. It would be a new capability we'd have to consciously develop.
Yeah, and for if someone is interested, it's something also that we are interested in the group. Okay, it's not only about building a rover. On the title slide of this presentation, we use the word poetry. Okay, and it's because sometimes we talk about making storyboards about we are talking about NFTs at some point, but NFT is not NFTs in the sense that each of our build has some kind of personality, okay, and it's kind of a uniqueness, okay. One is stubborn, and the other one is a sociopath and stuff like that, okay. And so the thing that this is more about the movement, okay. It's we work about designing the slides, designing the communication. There's some PR with integration with Twitter, with Discord, and all that. Okay, so it's not only about the technology. Okay, there is all this aspect involving people basically, and arts and every kind of creation. Okay, at some point we're talking about maybe creating some storyboard. Okay, some story around some of the rover. So if there is interest on non-technical aspects, that's also, I think, part of the broader picture around rovers or robots, basically.
I had an opinion about which one I prefer, but the longer I looked at them, I realized that it didn't matter to me, because whatever number of hours I allocate a week to working on rovers, I would spend half of it only on whichever option is chosen, and half of it still on exploring. So having a common goal, whichever one it is good for the community and for anchoring what I'm doing. But half of my time I have no idea what I'm going to do, but it's not going to be any one of these goals or a different goal, which is set. So if you want to vote, I don't have a vote anymore. They're all good ideas.
I think
feel
50%
similar.
is about, oh, sorry, right, go ahead.
I was just gonna say I feel similar to that sentiment, but also that some of the options feel like almost design criteria or threads that can be part of almost any goal, like making developing cheap rover for massive experimentation is like, if we're making reusable components that can be reused within cheap rovers, we're kind of collectively building recipes or blueprints that can be used by anybody to build a cheap rover. And we're kind of already building cheap rovers. That's sort of we didn't get into the whole new bot whatever we call the concept of new bots. But I think that's sort of core to everything we've been doing.
I think 2 and 3 has some similarity in my mind, in the sense that to do 2, you might need more 3, like in the sense like need some capabilities to be developed in order to, not a single person might do the entire stack for doing a mission Earth or something. So initially when I think when we discussed, there was another component to the build leader thing, like people who build around the builds and some capacity, basically option 3 in some way. So yeah, I was most thinking about like yeah, if I'm going to allocate more hours to the project, like I would like to like work on SLAM for all the builds or something like that, like instead of just focusing on my build. And because I'm not sure how much hours I can put on mechanical or electronic stuff, but I can explore in the software domain on the autonomy aspect of it. So yeah.
Thank you. But would we have some interest from people who joined today, because it's mainly the current members who are talking right now. For example, earlier we had a proposal from Nalini to work on the systems engineering, which sounds pretty compatible with options 1 and 4. In fact, okay. Because if we have a cheap swarm, it means we have more rovers. It means we have more of them to upgrade and to manage their versions and so on. Okay, so if it's manual work, it's a lot of work and it's really error prone. Okay, so this is what Nalini's proposal can be very valuable, right?
Yeah, I think I also am of the opinion that those things will have to be done for any of this, like FODA or systems engineering thinking are 2 items that I was focused on when I talked earlier. Those are some things we need to do. Any of these paths, 1 year down the line, 2 years down the line, those would be more useful as they are deployed and we start seeing the systemic impact of this, not robo on the lab or in the room, but when it gets out in the field, we start seeing all the implications. So any path we take here will still lead us to that place where we have to deal with all of that. So yeah, I mean, any path we take, we still have to do the systems thinking about how we affect others and others affect us, and how we update the rovers or robots in the field, etc. So yeah, so if I had to vote, I'll vote 1 for everything if we're counting votes. Yeah.
Okay, thank you.
So from my very fresh perspective, and with my head still spinning about the amount of stuff I don't know, of the 4 options listed there, the one that leaps out to me is actually number 2, because by focusing on something you can do here and now, I would hope you get the feedback you need to develop your design faster. And of course, that's not to say that precludes anything else, but just as an option, the need for testing and feedback seems like a really key one. And then when I think about how, I don't claim this as sort of proof that I'm right, but when I think about how people go and test their robots, they often, I get the impression that they take them out to hostile environments on Earth and see how they perform in those environments. Now, nothing I build in the next year is going to do very well in a hostile environment. If I can get it to roll around the floor by itself, I'll be deliriously happy. But just as a sort of a goal of feedback from real environments seems like an important one, which is what makes me think of option 2. And I have one question about option 1, which maybe has already come up, which is, have people thought much about heterogeneous swarms and having different robots for different conditions? I suppose the very first demo kind of was that, wasn't it? One rolling and one flying.
So it's so sorry, I will jump into the question, because that's a very good question. A swarm usually means a large number of identical agents. Okay, but the thing is something we didn't have time to discuss. But so Aniraj build contains a rover with wheels and a drone. Okay, so it's definitely heterogeneous. But when you look at the demo with the 2 spiders, they look identical, but in fact they are not. Each of them has a different wear. Okay, one is more tired on the legs, let's say. Okay, and one cannot walk straight anymore. Okay, so in fact the distinction homogeneity and heterogeneity is with robotics. In practice, it's always heterogeneous. Okay, I have a bunch of spiders. I have a bunch of humanoid robots from the same maker, with same serial number, stuff like that. I always have to do some extra manual work. Okay, so they are heterogeneous by default. Okay, when when we work in software, it's very easy to spawn copies, and so to have in simulation. That one of my problems with simulations, okay, is that it's very easy to have a completely homogeneous population of robots. In practice, it never happens. Okay, it's a servo is tired, and boom, we have actually different robots. Okay? So chip swarms. Sorry, from my perspective, chip swarms does mean heterogeneous robots. Anuraj, we are talking about your robots.
Sorry, I had some problem with the camera.
So the question was, in option 1, the chip swarms, do we consider heterogeneity? Because when we look at your build, for example, you clearly have two robots that are not the same.
Yeah, so they are quite different in that sense. Yeah, so like you need different, let's say, a kind of effort in building those rovers, or like, let's say, drone. So in the second one, a lot of software was already done. For example, Infinity. So I had less work to do, but if you're like starting from scratch, it's a lot of work. So I got a lot of help from the ESA lab itself. So the guys who open sourced the rover, the software was really well done. So I just used the software they had done. So a lot of effort was taken off my shoulders, but that's why you use open source work, right? So it's nicely done. And then everything is working like the first time I connected it. But for the drone, I had to like, even though it is quite simple to do, like I had to find out what's happening inside. So, but if I would have done the, let's say, am I still audible?
Yes.
Okay.
But we can see a cat on your image.
Yeah. Okay, let's forget about it. I'll speak. I've been having some problems with the camera, but yeah, so for the drone, I had some like initially had some problem like finding the correct SDK and then some parameters and like the data sheet. So it's the data sheet also is from DJI. So it was not very clear on how to teleoperate it. So yeah. But if I would have started the Infinity rover just from scratch, I wouldn't have finished in 1 year. Like in the entire thing, if I would have done it myself.
And do you think it makes sense to collaborate in the sense that you do the rover and someone else does the drone, and there is collaboration to make the thing work together?
Yeah, that would be easier to do. Yes, definitely. So that is the plan, like one of the goals for me in the next year. So to try to integrate the work you have done, Mayor has done, Victor has done, Rhett has done, to like try to integrate with VPN and like have more collaboration on the software side.
James, is that the answering your question about heterogeneity, and maybe perhaps also about working together?
Yes, yes.
So like you can choose any like a robot or rover for your work, and then like try to collaborate from the beginning if you are like want to take some like help from with the software side.
Also, yes, software is easier to start with, definitely. There is also, Mayer mentioned that he designed his library so that it's that one of the goals is to it's not only for the Spider, it's a software library, it's a supporting integration with Twitter, with Discord, and to read servo motors. So whether it's servo for a leg or servo for a wheel, there is little assumption, okay? So one of the ideas that Mayer mentioned was to take the same library on a different physical rover and to make it work out of the box. Okay, it's not there yet, but it's so if someone wants to join and collaborate, so for example, in the case of option 1, okay, but it's to take something that has been done, but for example, a piece of software, and to buy a different chassis, okay, and to use it there and to adapt the code so that it can work there too. Okay, for example.
I think we should be presenting our presentations we have prepared in the beginning of the year itself.
You mean now?
Not now, but like when the year starts next year.
Oh, okay. Yes.
So like then it's helpful for people who want to join.
Venkat, for the time management, we have what, maximum 5 more minutes, right?
Yeah, so we should start wrapping up and yeah.
Yes. Yeah, so a quick word on year 2. It seems to me that it's more toward option 1, in fact, okay? But perhaps it's because of my bias of understanding the detail, okay? Because, for example, James mentioned interest in option 3, but option 3 is also pretty much integrated from my point of view inside option 1, okay? So we'll see how year 2 goes, okay? But it looks like it's going to be a continuity of year 1, okay, where each of us continue on our own interest, and we continue the exchange. And several of us mentioned increasing collaboration. Okay, seems that this is where we are going to go anyway, right?
Yep. All right, so lots of good raw material, and we can continue discussions in the Discord. And yeah, I think Anuraj's suggestion of like doing our material early in January would be actually good. And we can, if we want, we can advertise it again and make some of our sessions open. So, Rovers 101, if we want to do that session early in January, we can just advertise that and have people drop in. All right, so I think that's it for this year's first ever Yak Rover demo meeting. Thanks everybody for attending, especially the newcomers, and hope to see you. Are we meeting next Monday? Next Monday will be 13th to 20th, right?
20th, yes.
Yes, so I'm game, and it's not yet into Christmas week, so yeah, I guess we'll be meeting next week then.
Yes.
All right. So hopefully James, Brian, Phil, Nalini, if you're able to join us, please do, and we'll get rolling.
That's good. Thank you.
Yeah.
All right.
Thank you.
Thank you very much.
Bye. Thank you, guys.
Go to bed, Eric.
Sorry?
Time to go to bed.
No, it's time to go to work now. The Tom is coming in a couple of hours, so yeah. But we have